Hello everyone, I welcome you all to this next video in the Spring Framework lecture series. We have come a long way since the start of this series, and along the journey we have learned so many concepts. I sincerely hope that you are practicing these concepts on your own time as well. In the last video, we learned some important concepts related to beans within the Spring Framework. Quickly recap, in the last video I covered the following topics. Number 1, bean scope. Number 2, component scanning. Number 3, beans wiring. Number 4, what can we inject? In today's video, I will throw some light on the practicality of the concepts taught in the last video. If you remember, we did implement the simulation of a real-world production application which sends communication to users over various channels. In that application, I was using XML to configure and wire beans together. In this video, I will first use the concept of component scanning and stereotype annotations to remove the XML bean configuration. Next, I will use auto-wiring to wire beans together, and finally, I will demo the running application. So without wasting any time, let us get started. If you haven't already, please subscribe to the channel, like the video, and share the content as much as possible. First, let me remove the beans.xml file. Since I will be using Java configuration and component scanning going forward, we don't need this file anymore. Next, let me add the component scan annotation to the config class. If you remember, we talked about defining base packages along with component scan. Base packages specify the package within which Spring will run the component scanning. I'm using me.upskill.spring tutorials as the base package here. Next, I am removing all the manually defined bean methods in the Java config, as I will be using stereotype annotations to automatically register bean definitions. Now comes the most interesting part. I will add the generic component annotation to all of the bean implementation classes. This will make sure to automatically register these classes as beans in the Spring IOC container. Do keep in mind that the default name generated for these beans is the uncapitalized, non-qualified class name. For example, in this case, the name generated would be default communicator D with a small case. Next step is wiring all these beans together. In the last video, we learned the concept of auto-wiring to wire all the beans together. Auto-wired annotation can be added to any field, method, setter method, or constructor. Here, in this example, I am adding auto-wired annotation to all the class properties. We don't even need setter methods for auto-wiring to work. So, I am removing all the getter and setter methods for the private class properties. Spring will use reflection to inject values into these class properties which are marked with auto-wired annotation. Next, let us use auto-wired annotation to wire all the beans as well. First is default email sender, adding auto-wired on all the three private class properties and removing setter and getter methods. Similarly, let me wire other beans as well. Kindly follow along. It should be very straightforward. Simply add the AutoAdd annotation to any dependent bean and Spring will inject that bean. Just checking to make sure that all the beans are wired together. Before I run the application, let me demonstrate the bean lifecycle as well. Here I am implementing both initializing bean and disposable bean interfaces. Initializing bean interface has a method after properties set which we need to implement. After properties set will be called during the initializing phase. Just make sure not to run any long running task in the initialization callbacks. These initialization callbacks will be invoked on the main thread, and if we do any long running task, it will halt the application progress. I am doing the console out here, but you can have any customization logic that you want. Destroy method will be called during the shutdown of the Spring IOC container. Again, I am doing the console out here, but you can have any resource cleanup logic that you want. As mentioned previously, make sure not to add any critical business logic in destruction methods as they are not guaranteed to be called. Next, as explained in the previous video, we need to have a register shutdown hook for the destruction methods to work. Doing so is trivial. Cast the application context to abstract application context and use the register shutdown hook method as I am doing it here. This register shutdown hook method will register a new shutdown hook thread on which close will be invoked. I also need to change the way I get access to the communicator bean from the Spring IOC container. I can either use the name default communicator or remove the name altogether. Finally, let me run the application. First is building the runnable artifact from the source code. Next is running the bundled jar using java jar command. Our application is running now. Here, the initialization callback is invoked on bean default communicator using some dummy values to test the application. During shutdown as well, we can validate that the destruction method is invoked. One last thing before I wrap up this video. If you recall, I talked about ambiguity while wiring beans using auto wiring. If multiple beans of the same type are present, Spring will throw an exception and application will fail to start. Let us understand this practically. I am implementing the email sender interface again. So now in our application context, we will have two implementations of the email sender. This would create ambiguity within the Spring IOC container. Copy pasting here the log line. This simple email sender will not delegate to any other subcomponents. Adding the component annotation. This would make it a bean. Now compiling and running the application again. Using java jar to run the application. As expected, Spring throws an exception and is complaining that multiple beans of the email sender type are present. To resolve this, let me use primary annotation. Using primary annotation will make sure that an implementation class behaves as the primary default bean for a particular type. In this case, email sender type. Compiling and running the application again, we can verify that primary resolved the ambiguity issue and application started successfully without fail. Using some dummy values again to test the application. We can also use qualifier in place of primary to resolve the ambiguity created by multiple beans of the same type. Qualifier has to be applied on the class property where we are injecting the dependencies. In this case, I am adding the qualifier to the email sender class property of the default communicator. So as you can see, I am specifically asking Spring to inject default email sender here. Compiling and running the application again, we can verify that qualifier also resolved the ambiguity issue and application started successfully. In this case, since default email sender is injected, it is delegating to multiple email providers. Again using simple email sender, rerunning the application. Now email is sent using simple email sender and the simple email sender is not delegating to any other subcomponents. That's it for today's video. Comment your doubts and suggestions in the comment box. Once again, subscribe to the channel, like the content, and share it as much as possible so that it will reach users just like you who want to learn new skills. Your support is the only motivation for me to keep making these videos. In the next video, I will cover following topics. Number 1, application environment. Number 2, internationalization. Number 3, container extension points. As always, thank you and keep learning. I will see you in the next one.